Assalamualaikum warahmatullahi wabarakatuh and very good morning. Again, today, okay, another chapter for computer architecture and organization, which is we were going to the chapter 1. So under chapter 1, okay, we have what we call the introduction of the uh, computer itself, computer architecture and organization. So here, I would like to start with what actually is the computer system. So a computer system, okay, basically a system that consists two major components, which is a hardware and a software. So the computer system, okay, they have an input output inside it, okay, around it actually. So the computer interface, okay, to the outside world is what we call the input output. So example of input output device attached to a computer is, for example, you have a keyboard, you have a monitor, you have a disk drive, okay, a floppy drive. I don't think you guys know what floppy drive is. Okay, so you have a lot of things, your thumb drives, your speakers, okay, your cameras, everything. So they are called the IOs, input and outputs, okay, of a computer system. So all this computer system, they operate using what we call an operating system. So the operating system is the one that integrate all those devices, all those hardwares under programs, okay, so that you can operate any kind of operations inside a computer as any function that you want to do. Okay, for example, you want to do video conferencing, you want to record a video, you want to do your assignments, everything, okay. So all of them, the collective functions of all those hardware, okay, is managed by the operating system so that you can operate your own functions later on. So inside a computer, there are a number of levels that you can represent a computer in a way. Okay, so the exact number is basically depend on the philosophical issue. Okay, so we have what we call the top level and we have the bottom level. Okay, the highest level and the bottom level. So the highest level uh, is what you have under your user experience when you use a computer, and the lower level is where you have more towards internal structures. So as for example, inside the slide here, you have the highest level is where you have the application programs, the one that you create things, you do your creative things, you watch movies, everything is at the application level. And a little bit below is high level languages. Okay, so high level languages is where you have the programming of the computers involved, programming of the programs. Okay, so you do the coding, everything to create the programs is high level languages involved. And then under it we have the assembly language, okay, or known as machine code. So when you compile these high level languages, okay, it become the assembly language, or we known as machine codes, which is a more like a binary, so that you can, the computer will understand what you want them to do. Okay, so under that we have a micro program, hardwired control. Okay, this is where you have all those components link each other. Okay, so and then you have functional units. Okay, functional units is the memory, the ALU, so the circuits that involve inside that creates the memory, they create the ALU. Okay, and then you have the logic gates, the one that creates the memory. Logic gates is a lot of components that create the memory. And finally, we have at the bottom one is the transistors and wires. So as you know, okay, there's a lot of you buy a CPU when you buy a PC. Okay, usually you will see that inside a processor, we mentioned about 25 nanometers, something like that. So that is the size of the transistors. Okay, so in one PC, in one CPU, you might have billions of transistors that help operate your PC. So how does actually these transistors operate? Okay, so these transistors, they operate like a switch. So you have the on and off. So when you on, it counts as 1. When you off, it counts as 0. So this is what we call a binary system. So all your programs, okay, inside your PC, okay, when you convert it into machine language, okay, they will be in the form of 0 and 1s. So when you operate in 0 and 1s, okay, so the machine will analyze those 0 and 1, and the transistors will conduct on and off operations for those according to those programs. So as example, okay, for example, you have a user type my name Shafiq here, okay, so the keyboard you type the names using your keyboards. So the keyboard converts the characters to a binary code. Okay, here is the operation that created by the keyboard. Okay, so they are transmitted to the memory, and CPU will process those codes inside the memory. So what is the CPU processing it for? Okay, in this case might be the CPU is processing it for it to print the words inside a document. Okay, so here is very old Pentium 4 CPU. So okay, since you can see a lot of newer ones, so I like to use that old one here inside my slide so that you will know how is the history works. Okay, so the CPU will change this binary, okay, process it into a binary that can be understandable by the printer. So the printer will push the ink into the paper according to the binary provided by the CPU. Okay, and then the printer prints those, will put the inks on the paper according to the instruction based on the CPU, and automatically it appears Shafiq on the paper. So this is a very systematic things here. So the computer language, okay, as I mentioned, it's defined by 0 and 1. So when you say 0 and 1s, usually we mention it as a binary, bit 0 or bit 1. Okay, so 1 bit means either 0 or 1. So there's a lot of program inside your PC, and there's a lot of representation of binary inside your PC. So it's difficult for us to analyze which 0 and 1 is for what 0 and 1. Okay, so here we have what we call bytes. Okay, so bytes is a collection of 0 and 1. Okay, so 0 and 1, which is in 8 bits. So this is used to represent characters as alphabets, letters, numbers, symbols. Okay, we characterize those bits as symbols that we can understand. So this is what we call, what we call ASCII encoding. Okay, so 8 bits is count as 1 byte. Okay, and then you have 2 bytes will be representing one word. So one word have how many bits? Okay, so one word have 16 bits. Okay, so this is used to represent the bigger number of characters, like for example the Unicode encoding. So Unicode might be languages like, for example, the Japanese language or Chinese language. So this is the representation that we have of those binary. So the representation that we have here, okay, represented by ASCII. Okay, so firstly you need to understand the number system here so that we can understand ASCII. So ASCII, okay, ASCII format, usually they use what we call hexadecimal number system. So hexadecimal is not like our common number. Our common number is 0 until 9, and then continue with 1 and 0. Repeat back until 1 and 9, and then continue back until 2 and 0. So this one I will mention in the next chapter. So ASCII, instead of end with 9, it will end with F. Okay, so you have 0 until F. So what is after F? After F is 1, 0. And then continue up until 1F. And then after 1F, become 2, 0. Okay, so here is where you have the hexadecimal for ASCII. So each hexadecimal digit is represented by 4 binaries. Okay, so if you look at 0 is all 0, 1 is 0001, and then 2 is 0010 up until F. Okay, so all ones representing an F. So let's take a look at the architecture and organization. Okay, what exactly the course name is, the architecture and organization. What is the difference? So what exactly is architecture? So computer architecture is the concept, design, and fundamental operational structure of a computer system. So it is the practical art of selecting and interconnecting hardware components to create computers that meet functional performance and the cost goal. Okay, so actually it's a design basically. Okay, this is a word. Design and fundamental operational structure. So this operational structure is the one that visible to the programmer, okay, and it have a direct impact on the logical execution of a program. So example of the architectural attribute is when we have instruction set, number of bits used to represent various data types, input-output mechanisms, and techniques to address those memory. So these are the architecture attributes. So when you say about computer architecture, it's the design of the computer itself. And when we say about the organization, this actually is the architecture first. So this one is a PC architecture where you see that we have the main processor, the main memory here, which is the RAM, random access memory, and then you have the sensors, okay, and the system managers. You have serial USB, network, graphics, disk, and audio. All this represented as an architecture. And then here is the CPU architecture. Okay, if you say that here is the main processor and here is the architecture of the main processor, how the main processor works. So when you see this is the general design. When we go to the specific design, means that we are talking about the organization. Okay, so the organization is the operational units and the interconnection that realize the architectural specification. So they describe the data path, data processing elements, and data storage elements. And organization is how the architecture is implemented. So basically, when you talk about organizational attribute, okay, these are hardware details that are not being concerned by the programmer. Okay, it's about the control signal, interface, okay, and also what kind of memory technology used. Okay, so this is example of organization. Okay, this is a very old motherboard. Okay, I think it's for quite 20 years ago. Okay, so you have the CPU, okay, that be attached here, and then you have this random access memory attached here. So this is a very old organization example of a computer. And the more latest one here, okay, this one is 2016, quite old actually. You even have even better one these days. So here is a more new motherboard. Here you see that it's a more sleek, more beautiful comparing to the previous one. Okay, and this is an example of organization of a computer of very old one. Okay, you see that you have a CD-ROM, floppy drives, okay, power supply here, fan, and then here is the motherboard that I showed you before. Attached inside here, you have the RAM, and this one is around 20, more than 20 years ago. And this one is around 4 or 5 years ago. So you see that you can have a little bit more beautiful designs of the electronics here. Okay, so here is the CPU and here is the graphic processing unit, GPU. So you have this graphic accelerator, 3 of them being used in this PC. Particularly this one is focused on gaming, I suppose. So sometimes, okay, you can have the same architecture but different organization. So 20 years ago, we have the same architecture that we use today. Okay, so what different is that they use a different organization to make the performance better. Okay, so almost every program that can run on original Pentium, okay, we see that this one, okay, okay, or A086 can run on Pentium 4. I'm not sure whether it can run on i7 or i9 these days. Okay, all computers in the Intel Pentium series have the same architecture, and each version of the Pentium has different organization of implementation. So if they can, if like for example you create a program for example coding for programming C, hello world, this CPU can run the same program like our Pentium, our Intel i9, i7 these days, okay, can run the same program as well. Okay, and even if you have an AMD based PC, those PC also can operate the program as well. So they are using the same architecture, so it will not have any problems in operating those coding. Okay, So architecture usually they don't change with different model, but its organization changes with the changing of technology. If you see these days electronics getting cheaper, so getting cheaper means that better performance. Okay, so in the near future we might have different kind of architecture which involve, like for example, cloud computing, and also not cloud computing, I'm sorry, it's called quantum computing. Okay, so this one is a concern in the future unless they have a stable bill already. Okay, maybe they will share it with the consumers. Okay, what I got here with me now is a couple of example of computers that we have these days. So some of them is quite small, like this one. Okay, and some of them is this one is our conventional computer based on what we have in our desktop these days. So if you look at this one is our conventional PC. We have this component that is important for the PC to work, especially where under this fan here we have our CPU. Okay, so and next to it we have our random access memory, and here is our hard drives. So this one big circuit board here is what we call a graphic accelerator. So this PC, this one, it cannot work without a graphic accelerator, but some of your motherboard for your PC, even without a graphic accelerator, it can still work. So there's a lot of variation of what kind of PC that you can make. So some of you may be focused more on being a gamer, and some of you even would like a simple most PC just to make it a home theater. So based on your requirement, you can create your own PC. You can build your own PC actually, according to what we have on the market. So this one is my old hard drive. So this one is based on HDD. So these days we have what we call SSD, and we have the SSD also come in a lot of form factors. It doesn't even use SATA anymore. We have one that uses M.2. Okay, so So in case you need to build your own PC, you need to know that you need a motherboard here and a CPU inside. Under this fan here is a CPU, so small circuit board, okay, like a piece of metal. And you need to have your random access memory and also your hard drives. Okay, no matter what form is it, but you need a required hard drives. So unlike normal conventional PC, we also have we have a smaller type of PC, which is this one is what we have, what we call a Raspberry Pi. Okay, Raspberry Pi, it works almost the same like our conventional PC. Okay, it has its own CPU which is under here, but the architecture of the CPU is different. Okay, in this case it's created by Intel, and this one is created by ARM. So ARM CPU focus more on to make it a little bit less power consuming comparing to what Intel did, and where Intel focus more in delivering performance. So here also we have its own, it does have its own RAM here. Okay, in this case I have around 8 gigabyte of RAM. One board here is 4 gigabyte, and another one is 4 gigabyte. So in Raspberry Pi, this one is Raspberry Pi 4 Model B, which is under 4 gigabyte RAM. Okay, you see that there's a chip here that representing the RAM. That before this one is very old PC. Before this, they have large one to representing 4 gigabyte RAM. Okay, so here in this board itself, almost half the power of the RAM based on what I have in my old PC here. So here it also have its own graphics accelerator inside it, so you can put it directly to the HDMI port. In this case, in this PC, I don't have, I have only one HDMI port here. So here you have two HDMI port. You can put it inside Raspberry Pi, and it has a lot of functions. If you look at this board, the side of the board here, okay, comparing to Raspberry Pi, Okay, Raspberry Pi, they have limited ports here, like 4 USB, 1 Ethernet, okay, 2 HDMI. Okay, so but in case of you have your own desktop PC, you can customize it according to what you want. So you might have a lot more boards like this graphic accelerator to plug in inside this remaining slot here. So some of them might help you to have better audios, might help you to have access to more USB ports, okay, might have access to other things, okay, that you need for your own projects or anything studies that you can have. So even these days, you can even have two graphic accelerator side by side together. So and then, okay, this is a Raspberry Pi. Okay, if you look at this one, it can run on Linux, and this PC also I previously run it on using Linux as well. So both of them can run Ubuntu 16 perfectly. So you should not have this one is sorry, this one is Raspbian. Both of them can run Linux perfectly with certain limitation. Okay, like for this one, okay, they have a little bit limitation comparing to the hard drives, but I think it's almost similar these days because this one is the latest one that we have. So other than that, we have also different organization of the PC, but it's not entirely correct if you call it PC. This one is where you have Arduino Uno, Arduino, two types of Arduino Uno. Okay, Arduino Uno, they are called microcontroller, so they don't have a proper OS inside it. So you just burn the program inside the board, and then it can operate perfectly. So other than that, comparing to Arduino and our conventional PC, so this PC, they have their own OS, which is in this case both of them are installed Linux previously. So in our conventional PC, we can run on Windows, okay, we can run on any other Linux based OS that you have. Even the Mac OS also, they have the same architecture as our normal PC. So in this case, you look at, okay, what represents the difference between all these devices is the organization. Okay, so all of them are based on stored program concept, means that you install, you insert, you burn the program inside the board, and the board will run it for you. So in this case, every program will be inserted inside the hard drives, called back by a random access memory, and operated by the CPU. Same thing here. So you have its own drive. In this case, you have an SD card down here. Okay, so the SD card will call, the data inside the SD card will call by the RAM and will be processed by the CPU. Same thing here in Arduino Uno. So it has a little bit limited space just for you to flash a small program inside it, not an entire OS. And it also have its own RAM, a couple hundreds of megabytes, and it has its own CPU, ARM based. So what different between all of this is the organization basically. Okay, the architecture is still a stored program concept under the von Neumann architecture. So you have these days, we have a smaller PC day by day, and in the future, maybe later on, we can even have a much more smaller PC. Okay, so what I have here is another one called Node MCU. Okay, here we have a type, it's not Node MCU, it's an Espresso Lite. Okay, version 2.0, so which I use one of my IoT projects here. Okay, so it's also the same concept like the Arduino, okay, but much more smaller than this. Okay, so there's Arduino also have a lot of organization style. So here we have Arduino Leonardo. So you have Arduino Uno, and then you have Arduino Yun, and this one, okay, the old Uno, and this one is the newer Uno. Okay, you see that what difference between them is the organization. Okay, and based on the organization, they can add some more functions, some more ports for you to access for any projects that you have. Okay, so basically, why do we need to study computer architecture and organization? So we need to understand that the computer system function components and their characteristic in order to achieve the high performance system. So we need to understand that the computer architecture is, we need to understand the computer architecture to structure a program so that it can run more efficiently, and so that, and later the third one is able to select the most cost effective computer for the use of the organization. So I think that's all for today. Okay, so I will continue the next section later in another video. Okay, and then hopefully you guys stay tuned with me for our next class and under my next video. So that's all for today. I'll see you guys later. Stay safe, stay healthy, and take care. Assalamualaikum. Bye bye.